In a previous video, we saw how we can make simple adjustments to the sample project robot by using the attachments dialog. In this video, we'll go through the process of setting up our computer to work with our own simulated models by using LEGO Digital Designer and the LDraw parts library. LEGO Digital Designer, or LDD as it's more commonly known, is a CAD tool that can be downloaded for free from the LEGO website. LDraw, as we saw in our installation video, is an open source CAD format for working with 3D LEGO models. It too can be downloaded for free from LDraw.org. Having the library installed will greatly expand the number of bricks that we can import into the simulator. Simply select your platform and then look for the link that says AIOI or All-in-One Installer. Click to download. When running the All-in-One Installer, we really only need the parts library. We can unselect MLCAD and LPUB as a disk saving measure. Click the Next button to specify an install path for the library, and then finish the installation. To tie up any loose ends in the simulator, we can close the Welcome window and go to the Help menu and select Patch LEGO Digital Designer. This will help to ensure that LEGO Digital Designer is updated to work with the newly installed LDraw library. Now in a future video series, we'll actually learn how to build using LEGO Digital Designer. In this tutorial, however, we'll be working with a completed model to document the import process. We start by clicking on the File menu in LEGO Digital Designer and choosing Export Model. A new window appears. And I'll give my file a name and choose to save it in LDraw format to my desktop. At this point, I'm finished working with LEGO Digital Designer, so I can close the program. If you chose to install LDView, you will see a preview of your exported model. Make sure that no pieces are missing, because if pieces are missing, this is an early indication that parts of the LDraw library did not install properly. Within LDView, we can rotate our model to verify this. Back in the simulator, I'll click on the sample project robot and press my delete key to remove it. Here on the toolbar, there is a button to import our robot. I'm asked to locate my LDraw model, which I've saved here on my desktop. And what happens next is the simulator begins parsing the LDraw file to begin the process of assigning physical attributes and constraints to our model. Next, I'll be asked to identify various components that make up my model. The simulator identifies the main chassis or body of our robot, which displays in green. It also sees that this model has a caster wheel at the back, and that too also displays in green. The robot has a small shovel, or pusher if you will, mounted to the front of the chassis, which again displays in green. A right wheel is also found, and a left wheel. Now, to make it easier to work with my model, I may elect to give the components more meaningful names. For example, renaming Component 1 the chassis or Component 2 the caster. This is entirely optional, but I believe strongly in doing it as it helps to avoid a lot of confusion down the road. With my components now identified and renamed, I'll mention one last option that you may want to consider using. Larger, more complex models can result in a lot of memory overhead, causing the simulation to run very slow. To boost performance, we can merge components together, meaning that the simulator has one fewer thing to keep track of. For example, this pusher should be treated as an extension of the robot's chassis, since it is unlikely that the pusher will ever move independently from the main body. After merging the chassis and the pusher, we can see that the pusher disappears from the components listing and now displays in green when the chassis is selected. Next, the two motors on my robot are identified. Again, this is a case that I'll want to give them each a meaningful name and assign the two to ports on my virtual brick. The selection highlighting in the preview pane indicates the motor that we are working with, and here you can see that is the case when I select my left motor and rename it. Here I'll choose a port for each motor. This is analogous to us wiring the motors on the physical brick. And if I had sensors on my model, we would be given the option to map them to numbered sensor ports below. Since I have no sensors, I'll click the next button to continue, and the very last step is to specify a set of keyboard controls to drive our robot. One thing you'll want to pay particular attention to is the direction our robot is facing. The import wizard needs to know which direction is the front of the robot, because the keyboard keys we select to map our movement will be relative to the front of the robot. In both cases here, I will select the WASD keyboard keys to drive and control the left and right motors. When finished, I'll click the next button, which will cause the import wizard to finalize the model. And what's happening in the background here is that the simulator is actually flexing our model to make sure that everything is properly constrained. When this internal testing is finished, we can click on the next button to exit the import wizard. The import wizard will usually place our imported model at the center of the project file, which is not quite what we're looking for in this particular case. So instead, I will use the directional arrows to reposition my robot to the side of the mat. And as you can see here, with the simulator started, I can now use the WASD keyboard keys to control my robot and drive it around. But even more importantly, our simple 3D picture has now made the transition a fully physics-enabled model. If I go into the Render menu, Enable Physics, and select my robot, we can see that it lights up like a Christmas tree because it now has stuff. In this video, we saw how we could combine several freely available tools such as LEGO Digital Designer and the LDraw library to create a sophisticated data-driven simulation. If you're a first or a WRO mentor, just think now of all your team members and how they can all be involved in the design process in working with the physical robot, even if it's missing.